Pressure washing generally refers to the practice of using high-pressure water flowing through a nozzle at high velocity to clean various surfaces. One difficulty with this technique is that it creates wastewater which is contaminated with the undesirable substances which were removed during washing. Without intervention, this polluted water will eventually flow into a nearby waterway. This kind of pollution can be avoided by the use of the following best management practices: planning, pre-cleaning, use of proper cleaning techniques, wash water collection, and proper wash water disposal. Properly executed pressure washing can actually be beneficial to the environment by removing, collecting, and properly disposing of material which would otherwise eventually wash into waterways. Pressure washing generally refers to the practice of using high-pressure water flowing at high velocity through a handheld wand and nozzle to clean a variety of surfaces. The mass and velocity of the water provide an effective cleaning mechanism for quickly and efficiently removing material such as paint, grease, mold, and dirt from a variety of surfaces. Pressure washing is particularly useful for cleaning irregularly shaped or textured surfaces. One difficulty with this technique is that it generates a volume of water which is contaminated with the undesirable substances which were removed during washing. Without intervention, the pollutants in this water will eventually make it into a nearby waterway. This is bad for the environment and also illegal in the United States. This module will introduce the topic of pressure washing and cover how to accomplish it in a safe and environmentally friendly manner. All pressure washers have the same basic components: a power source, which is a motor or engine, and a pump to increase the pressure of a flowing stream of water. Pressure washers vary significantly in size. Units designed for home use are powered by an electric motor or small gas engine and produce pressures from 1,500 to 3,000 psi at flow rates of 1 to 3 gallons per minute. These are commonly used to clean house siding, sidewalks, driveways, vehicles, and lawn furniture. Large industrial pressure washers are powered by automobile-type engines and produce pressures of up to 60,000 psi and flow rates greater than 20 gallons per minute. These can be used to remove deposits from the exterior and interior surfaces of process equipment and piping that might otherwise be very difficult to clean. Pressure washers use positive displacement pumps to significantly boost the pressure of the water that is supplied to the pump. The boosted water flows from the pump through a hose to a wand with a trigger-type valve at one end and a delivery nozzle at the other. The small opening in the nozzle is where the energy from the pump and the high pressure of the water is converted to a high-velocity water stream or spray. The trigger valve is pulled to start the stream of water and released to stop it. Most pressure washers have a provision to add a cleaning agent to the water stream to increase the effectiveness of the washing. Some professional models also provide a method to heat the water prior to its discharge. The most significant hazard of a pressure washer is the high-velocity water exiting from the nozzle at the end of the wand. All of the energy of the engine or motor is focused into this narrow stream of water. Even in smaller home-use units, the water exiting the nozzle is moving at the same speed as a BB from an air gun. This gives it the ability to abrade and/or penetrate the skin. For this reason, never point or aim the wand at yourself or anyone else. Never put your hand or any other body part directly in front of the nozzle. Always wear eye protection, as the force of the water stream can accelerate small particles removed from the work surface and sometimes cause them to ricochet back into your eyes. Other safety guidelines for pressure washing include: always wear hearing protection. Pressure washing is a noisy operation. If the pressure washer is powered by a gasoline engine, be aware that many parts of the engine are hot enough to burn you, so avoid contact with the engine. Gas engines should never be operated in enclosed spaces due to the fact that the exhaust gases are poisonous. If the unit is electrically powered, make sure that it is plugged into a circuit which is protected by a ground fault circuit interrupter, or GFCI. Also make sure that the power cord remains as dry as possible and does not run through the work area. Pressure washing is usually very effective. It is tempting to believe that by simply moving the wand over dirty surfaces, they are made shiny and clean and the dirt simply disappears with the spray. That is, of course, not the case. The material that is removed, be it dirt, paint, or grease, is simply reduced in size and mixed in with the water from the pressure washer. This contaminated water is considered a process wastewater at this point, and its disposal is subject to a variety of federal, state, and local regulations. In order to protect the environment, process wastewater is not allowed to enter any body of water in the U.S. without a permit. The problem is that most public hard ground surfaces drain to storm sewers, and storm sewers carry whatever flows into them without treatment directly into the nearest stream, river, or lake. This means that without intervention, the soap, grease, and other contaminants created by pressure washing every car engine, drive-through, and parking lot will ultimately flow into natural waterways. The easiest way to prevent this type of pollution is to capture and collect the contaminated wash water close to its point of origin and then dispose of it in an environmentally friendly manner. Pressure washing does not need to have a negative impact on the environment. Removing, collecting, and properly disposing of a material which would otherwise eventually wash into the waterways can actually have a beneficial effect on the environment. Pressure washing best management practices, or BMPs, are behaviors that reduce or eliminate the environmental impact of pressure washing. BMPs for pressure washing include planning, pre-cleaning, use of proper cleaning techniques, wash water collection, and proper wash water disposal. We will shortly look at each of these practices in a little more detail. Most jobs that are properly done require planning. When planning to pressure wash, first perform a site evaluation. Determine how wash water will flow, where it will try to enter the stormwater system, and how to best contain and collect it. Develop a plan for disposal of the collected wash water. Permission, permits, or hazardous material hauling may be required. All of these should be in place before actual washing starts. Most surfaces can benefit from dry pre-cleaning. Dirty wash water, which might otherwise be able to go into a sanitary sewer, cannot be sent there if it also contains plastic wrappers and other solid trash. Sweeping or vacuuming an area prior to pressure washing collects solid material and prevents it from mixing with the wash water. Scraping accumulated grease from parking spots or soaking up liquid oil with an absorbent prior to washing has the advantage of keeping the grease and oil in a relatively concentrated form, thereby reducing disposal costs. It also reduces the amount of contamination in the wash water. Pre-cleaning improves the quality of effluent wash water, and it reduces the quantity of water required to clean a given area. During the actual washing process, the goal should be to accomplish the job while creating as little waste wash water as possible. Move across the work area in a systematic pattern. Re-washing an area that has already been washed unnecessarily increases the volume of wastewater. Consider using environmentally friendly cleaning agents. By loosening and dissolving dirt, the use of detergents can reduce the amount of water needed to clean a surface. Select the correct washing pressure. A pressure which is too low will result in ineffective washing and the need to move more slowly, leading to increased water usage. A pressure which is too high will lead to damage to the surface being cleaned. Select the correct nozzle tip. A wide spray pattern will affect a large area, but may be ineffective, similar to having too low a pressure. Too narrow a spray pattern will clean well, but due to the low coverage will increase the wash time, again leading to excessive water use. The primary technique used to protect natural waterways is to contain the wash water and prevent it from entering the stormwater collection system. The collection method is dependent on the job being performed. If a vertical surface like the wall of a house is being washed, tarps can be used to collect wash water before it actually contacts the ground, and the water can be sent to a collection area. If the goal is to wash an item like a car or some lawn furniture, tarps with integrated inflatable berms around the edges can be used to collect the wastewater. If the surface being washed is a ground surface, such as a driveway, effluent can be collected into a large puddle or small pond within temporary berms. Berms are long, low, flexible, waterproof logs, which are laid on the ground to prevent water from flowing past them. If the work area naturally slopes toward a storm drain, the drain can be temporarily blocked with a flexible cover, which allows the water to collect in a pool above the drain. Once the washing is complete, the collected water can be pumped or sucked to a disposal area or holding tank. Vacuum booms can also be used. These are hollow booms with small holes in them. A vacuum boom is connected to a wet vacuum device such as a wet vac, which continuously pulls air and wastewater from the containment area into the boom and then into the holding tank. This type of boom helps prevent overflow and saves the time needed to pump or vacuum up collected water once washing is complete. The proper disposal of collected effluent is dependent on the types of contaminants in the wastewater. The wastewater created and collected during most domestic pressure washing activities can be put into a sanitary sewer or dispersed into a landscaped area of ground, as long as it does not contain hazardous chemicals. Local regulations may require testing and a permit in order to perform either of these activities. As mentioned earlier, storm drains discharge directly into waterways. The reason non-hazardous wash water can be put into sanitary sewers is that these sewers first discharge into a treatment plant. A typical treatment plant uses several process steps to minimize or eliminate the impact of common incoming contaminants before finally releasing the treated water into natural waterways. Regular testing of the effluent from treatment plants assures that it is safe for release. If pressure washer effluent is known to contain any hazardous materials, for example, lead paint chips, The collected effluent must be disposed of by a licensed hazardous waste hauler.
Hot water pressure washers are ideal for cleaning heavily soiled surfaces. They help you get the job done quicker and more efficiently than a cold water pressure washer. This video will show you the proper startup, operation, and shutdown procedure for a gas-powered hot water pressure washer. As with all gas-powered pressure washers, always operate them in a well-ventilated area. Always wear safety goggles and closed-toe shoes, and protect yourself from the possibility of direct spray. Do not come in contact with the engine, muffler, or heat exchanger. Make sure the pressure washer is on a flat surface and the brake is locked. Check the pump oil and engine oil level before each use. Use 85 octane gas for the engine and either number 1 or number 2 diesel fuel or kerosene for the burner supply tank. Connect a garden hose to the pressure washer and the other end to your water supply. A 20 to 40 psi inlet pressure supply is required. Next, connect the male end of the high pressure hose that comes with the unit into the coil outlet on the pressure washer. Be sure the trigger gun is in the locked off position. Turn on the water and move the trigger gun lock to the on position. Squeeze the trigger on the gun to purge the system of excess air before starting the unit. Now you are ready to start the pressure washer. Turn the engine switch on and the gas lever on. Slide the choke lever to the open position and the throttle lever to the left, or the full throttle position. Make sure the burner switch is in the off position. Holding the gun assembly firmly in your hand, point it in a safe direction and squeeze the trigger to release the pressure. Failure to release the pressure will make it impossible to start the engine. Pull the recoil on the engine. The engine should start on the first or second pull. When the engine starts, release the trigger gun and close the choke. At this point, the unit is operating as a cold water pressure washer. It is important that you make sure the pressure washer never runs in the bypass mode for more than 2 minutes. To operate as a hot water pressure washer, move the burner switch to the on position. On initial startup, water will begin heating in approximately 20 seconds and will reach maximum temperature in approximately 2.5 minutes. As you can see, hot water pressure washers have an advantage over cold water machines for specific cleaning applications. To remove oil, grease, tar, or other sticky substances, such as gum in a stadium, there is nothing better than a hot water pressure washer. For even greater cleaning power, use detergent that is specifically developed for use with your hot water pressure washer. First, put the detergent hose into the detergent container and open the detergent valve on the pressure washer. To begin drawing detergent, you must open the handle on the dual lance wand by turning it clockwise. Mighty M detergent is specifically designed to break down dirt, grease, and oils for more cleaning power than water alone. Plus, Mighty M detergent is environmentally friendly. When you are done applying detergent, turn the dual lance wand counterclockwise until closed. Close the detergent valve and rinse the surface thoroughly. When your project is complete, take time to cool down the coil of your pressure washer. Turn the burner off and squeeze the trigger for approximately 1 minute, or until the metal lance feels cool to the touch. Heated water pulls the metals out of hard water and allows them to collect on the coils, so cooling the coil is very important. Turn the engine switch to the off position. Turn the gas lever off. Turn off the water supply and pull the trigger gun to release pressure. Disconnect the high pressure hose from the unit. Disconnect the garden hose.